Hello. Welcome to the Watt Hour, our first episode of the new year. And today we're going to talk about the power behind everything, a short history of lithium ion and the future of energy. I'm William Hadala. I'm the Chief Strategy Officer here at American Lithium Energy. And this is our first episode of 2026. And I wanted to start at the foundation, not with hype or not with buzzwords, but with understanding. Because whether it's your phone, an electric aircraft, a satellite, a robot, or a data center, everything in our modern world runs on stored energy. And most of that energy comes down to one thing, the lithium ion battery cell. So today I'm going to give you a clear high level view of where lithium ion came from, how battery cells actually work, why they matter across industries like aerospace and defense, and what makes American Lithium Energy different as we move into the decade. So there's no sales pitch here, it's just the facts explained simply. So many of you are probably wondering, what is a battery cell really? So let's start basic. A battery cell is not a battery pack. It's not a system and it's not software. It's a cell in the smallest unit of stored electrical energy. So a cell is the smallest unit of stored electrical energy. And inside a lithium ion cell are four essential elements. There's a positive electrode, a negative electrode, a separator, and an electrolyte that allows ions to move. What that means is that when a battery's charging, lithium ion moves one direction. And when it's discharging, like it's powering something, they move back. And that's it. There's no magic. It's just physics, chemistry, and control. But here's the key point most people miss. The cell, meaning the battery cell, determines everything. It determines its performance, safety, lifetime, temperature tolerance, and reliability. You can build the smartest battery pack in the world, but if cells or the battery cell is weak, the entire system fails. A dirty little secret in our world today amongst the battery industry is that most people think batteries are batteries, that they provide energy. They do. But inside of a battery is a cell and a battery pack. A battery cell and a battery pack make a battery. So it's important that there's an understanding of what a cell is. Now, a real short history of lithium-ion battery is that lithium-ion batteries entered commercial use in the early 90s. They replaced older chemistries because lithium offered higher energy density, lower weight, better rechargeability. And that's why lithium-ion became dominant in consumer electronics, aviation, space systems, industrial equipment, and eventually electric vehicles. Over time, manufacturers pushed for more energy and lower costs with faster charging, but safety often lagged behind. Now, I'm sure you've heard like thermal runaway and fires and catastrophic failures weren't accidents. They were what we would call trade-offs. The industry optimized for volume and price, not resilience. And that approach worked fine for disposable consumer products, but it doesn't work for aircraft and spacecraft, autonomous systems, or critical infrastructure. Which brings us to why advanced applications demand a different philosophy. And that's where we segue into why aerospace and high reliability systems are different. In aerospace or any mission critical system, you don't get a second chance. A battery failure isn't an inconvenience, it's a system level event. And these environments demand wide temperature operation and ranges, predictable degradation, long-term storage stability, and intrinsic safety at the cell level. Let me say that again, intrinsic safety at the cell level. That's why battery cells for aerospace and advanced platforms are engineered, not commodity products. They're designed for cold starts and altitude, high vibration, long dormancy, meaning they can be stored for a period of time, rapid power delivery, and controlled failure modes. This same thinking now applies beyond aerospace. And so now we're working with robotics and edge data centers, grid adjacent energy storage, autonomous vehicles, as well as in advanced manufacturing. So the world, as you know, is becoming more electrified and more unforgiving. And why American Lithium Energy does things differently. It was founded on a simple belief. And that simple belief is safety and performance must start at the cell level, not be patched in later. For over a decade, ALE focused on advanced cell chemistries, built in safety mechanisms, and US based engineering and manufacturing. And in 2026, that matters more than ever. As you know, supply chains are under scrutiny, traceability is non negotiable, and domestic manufacturing isn't a slogan, it's a requirement. And so ALE designs and manufactures lithium ion cells with high energy density, high power capability, intrinsic safety features, and full material traceabilities. And these cells just don't power systems, they enable trust. And that trust applies whether the application is commercial, industrial, or national scale infrastructure. As we move on, where energy storage is headed, looking forward, energy storage is moving in three directions. The first is higher performance per unit volume, smaller systems doing more work. Second, integrated safety by design, not reactive protection, but preventative engineering. And the third is convergence. Batteries integrated with AI, power electronics, edge computing, and autonomy. So energy storage is no longer passive, it's becoming intelligent. And the battery cell remains the foundation of all of that. So in this episode, we talked about understanding what a battery cell is, not selling. Because if you understand the battery cell, you understand the backbone of modern technology. We at American Lithium Energy have built out what we call a mega factory, a factory here in the United States that builds battery cells from the slurry all the way out to the formation with the ability to produce gigawatt hour capacity. And that's very important, especially with domestic manufacturing of battery cells with full traceability that's NDAA compliant. So we'll talk more about that. So in future episodes of the Watt Hour, we'll dive deeper into different battery chemistries, into safety innovations, manufacturing readiness, and into how energy shapes the future of everything from cities to space. If this episode was useful, please like, subscribe, and share it. Can't do this without you. So this is the Watt Hour, and this is where power meets purpose. Have a great day and make it great.